Takže dobrý den, vítám vás na Fakultě informačních technologií. Já jsem Pavel Černík na této fakultě. A tady s kolegy, kteří zaštiťují teda vaši zájmovou skupinu, jsme se domluvili, že začneme tenhle semestr sérii přednášek a setkání vaší skupiny v našich prostorách, takže budete mít k dispozici jednak v třetím patře takovou konzultačku, když vás bude méně a budete chtít třeba provozovat svoje programátorské soutěže, a nebo když bude nějaká větší přednáška pro větší skupinu lidí, že to může být v těchto prostorách. No, budeme to normálně zveřejňovat na našem webu. Předpokládám, že sem bude chodit mezi vás i hodně našich studentů, který je Scala zajímá. Máme tady inženýra Janecka, který ho přednáší jako volitelný předmět bakaláři, tuším. Že tam, já nevím, je tady někdo z vás, mezi vámi, kdo tam chodil už ten předmět. Takže tam máme taky rok asi několik desítek studentů, kteří se tomu věnují. No a je to věc, kterou jako na naší fakultě chceme dát rozvíjet, takže to možná, doufám, že začátek nějaký širší spolupráce, kterou s vaší skupinou a s vaší iniciativou teda časem vymyslíme. Takže vám přeju, abyste tady našli prostředí pro to, abyste o Scale tady vám dobře přemýšlelo, abyste zmínili radost a doufejme teda, že tímto vám k tomu pomůžeme. Já se zase musím vzdálit, takže vám přeju příjemný večer a naschvál.
Okay, I'm going to switch to English. I see you're over there. I guess no one has a problem with English. It's actually we held in English. I'd like to welcome you here on our first event after the alleged end of days. Last year it didn't happen, so we will continue in our activity doing core events in this wonderful place. See more people are coming. Today's lecture will be about dependency injection in Scala, which is brought to you by Vlasta. We will start with the dependency injection frameworks you know from Java, so Spring Framework, the Google Guice and CDI. He also introduces a Spring Scala, which is a completely new stuff from Spring. Then Jakub will go on with the pure Scala dependency injection framework, and we will end Michal, thank you, with the way how Scala deals dependency injection code frameworks in a pure language way, which is a K pattern. We will have a short Q&A after each segment, so please save your questions. Each segment will have 10 to 15 minutes. Enjoy.
Can everybody hear us, or do we need to use the microphone? Okay, so good. Okay. So let's start with the dependency injection frameworks you know from Java. And the big question is if you can continue using them when you start using Scala. And if you want to get the briefest brief of all, you can use them still. And it's important because maybe you want to use Scala in existing Java project or platform where you can do some new stuff in Scala, and it has to interoperate with existing stuff you've done in Java. So I think that's important. And the reason the stuff just works most of the time is because the bytecode is the same. Scala classes compile to basically the same bytecode as Java classes, so the Java dependency injection frameworks don't really see any difference most of the time. And as with everything, there are some issues, and we'll get to them later. So the first framework we'll cover here is Spring. I think that most of you, if you're Java programmers, are familiar with Spring, so we'll not stay with it for a long time, but just a quick summary. I think that Spring is the most popular dependency injection solution in Java. It's used by quite a lot of people, and I think, or it's my opinion, that there are reasons for that, because I think that Spring is well designed, and it also is today a lot more than just a dependency injection solution or inversion of control container. There are a lot of other stuff built in Spring, so there may be other reasons than just dependency injection for you to use Spring. And because the Spring is most popular, a lot of people tried or experimented using Spring with Scala already. So there's a good chance you'll find some solutions on the internet or Google some problems you may find. And also, last year, Spring Source started to work on the Spring Scala project, which is I guess, extension or add-on to the Spring framework, which goal is to make using Spring from Scala more friendly. We'll cover that in a separate section. So let's look at our examples we'll be using in this whole presentation, and we'll be making coffee. The example is quite trivial, but there's no time or space to work with more involved examples. So we have an espresso machine, which is a component that has three dependencies: the water heater, grinder, and a foamer. Those are interfaces, and they have each one has two different implementations. It's not really important, but differences of those implementations are not important. Just sometimes you want to choose which one you want to use. And the espresso machine makes coffee, so that's like the product we want to make. So let's start with a first example. This one is Spring used with the annotations. There are basically three ways how you can use dependency injection in Spring. The old way, which was everything in an XML document, no annotations, no nothing. Here we're using an annotation-based approach, and there's also an approach more similar to Guice, which basically means you create your configuration in Java and wire the things manually. So this is Scala code, and the only interesting thing you can see here is how you can put an annotation on a constructor in Scala. It's this piece of code, and that's the only interesting thing here, because everything is the same as in Java. You put the component annotations on the classes, and you put the auto-wired annotation on the injection point, the place you want the Spring to inject the dependencies in. Here we can see we're using a constructor-based approach, because it's natural to use this in Scala. We'll see another example later. Here just a quick comparison with the same code in Java. Like nothing important here, just the same thing. You see it's a little more verbose, but that's not something we need to cover here. You still need some XML even with the annotation-based approach in Spring, but it really boils down to just like two stuff you need to do. You have to tell the Spring you are using annotations, and you need to tell which packages it should scan for the annotated classes. It's really not something terribly interesting, but you need it. And as we saw, the differences between Scala and Java in this approach are quite minimal. It's really just the maybe weird way for some people who are not familiar with Scala, how you put inject annotations on constructor, and the constructor itself seems a little different than in Java, but really nothing so different. But as I show here, the example used constructor-based injection because it works really well with immutability, which is the natural approach in Scala. In Scala, you really, most of the time, don't want to make your objects mutable, and the other approaches in Spring, that is the setter-based injection, really requires your classes to be mutable. So let's look at an example. This is an example of a setter-based injection in Java. There's no constructor. You just create basically a Java bean style setters. You don't need any getters. And you annotate it with the auto-violet annotation. You still can use this approach in Scala, but it's not so nice as the constructor-based approach, I think. Here we can see two approaches how we can do that. The first one is at the bottom is the setFormer method, which is a setter which you have to write by yourself. Again, the difference is just the syntax, and you put the auto-violet annotation directly on the setter. You can use some special compiler helpers or syntactic sugar if you want. In Scala, you can tell the compiler to generate Java Bean style getters and setters without you needing to write the code yourself. So you just create the mutable field, the water heater, and you put the bean property annotation, and this thing will generate a Java style getter, a Java Bean style getter, and a setter in the generated class file. So, and you need to put the auto-violet annotation just on the setter, so Spring would not be confused. And you do that by using this special meta annotation, I would call it, bean setter, which you're telling the compiler that you want to put the auto-violet annotation just on the bean setter. As you can see here, it's not very pretty, I would say. Certainly nothing special, or you don't get anything more or nicer than in Java. So I would recommend sticking to the constructor-based approach. So far so good. We just saw one, maybe small, maybe larger issue for someone, but we'll see other issues later. Let's move on to the Spring Scala project. It's a relatively new initiative. It's developed directly by Spring Source, and it's not really stable yet, or there is no final release. It's still in the milestone stage. It targets the latest Spring release, the 3.2, and it's a little Scala library or a wrapper that allows you to do two things. The first one is you can wire the beans using a functional, a more Scala-friendly syntax, which we'll see later. And also it contains some functional wrappers for the Spring templates. If you know Spring templates, like Hibernate template, ABC template, and stuff like that, the API for that uses a lot of anonymous or callbacks, which you typically implement with anonymous inner classes. which is not very nice and certainly not used in Scala. In Scala, like the natural approach to this would be using functions. So you can do that if you use Spring Scala. We'll not cover the templates, we'll just see the functional configuration. The first differences with to the first example, there's no annotations. The rest stays the same, so the classes are just the same, but without the annotations. And here we see the functional configuration. The configuration objects extends this functional configuration class, which comes from the Spring Scala project. And as we see here, that the whole thing here is in the body of the primary constructor of the class. So when the new instance of this class is created, this code is called, and it uses this special method that comes from this class, and the bean method registers a bean creation function, which is this thing, and it gives you a lookup function, if you want to call it like this. So you're basically saying you're creating a new bean in the application context or in the configuration, and when you need an instance of this bean, the body of this or this function that is registered here will be called, and it will create this manual folder, which is the implementation. We see it used 3 times here, and so we create 3 beans, one for the manual folder, rough driver, and fast folder here, and we use them later, these functions that we created here, when we create the bean for the espresso machine, which in the creation function for this bean, we use the lookup functions that we've created at the top. So it's quite different than the annotation-based approach, but it's actually not that different from the Java configuration approach or the modules approach from Guice. You just basically wire everything yourself. You manually set up the dependencies and which is implemented by which class. And the second part, after you do the configuration, you need to get the beans from the application context, and you do that by creating the functional config application context, which is a quite long class name. And this class comes from the Spring Scala project as well. And you give it the instance of the class of the configuration, and later you can call the getBean method that is contained in the I guess application context or bean factory interface for Spring. So this here is nothing new. It's a method from the old from the application context, but the new thing here is this class. So you access the beans using this method. Oh,
Questions?
Are there any questions so far?
Well, how you link two configurations together?
I'm sorry, please use microphone so the question will be heard on the video.
Sorry, in a Spring Java config you can import another configuration or XML configuration. I suppose it's here the same?
Yes, it's the same. The functional configuration has methods like import XML or import something.
Makes annotations, or is it just...
No, there are methods. I don't know how you pass the XML. If you pass a resource name or file or something, but there is way how to import another sources of the beans. That is the same as is in the Java config. Okay, so let's move to
Other questions?
Okay, let's move to Google Guice. Google Guice is a lot more simple than Spring framework. It basically focuses just on the dependency injection. It doesn't have this broad approach as Spring. There are a lot less things to learn if you want to start using Google Guice. So it's easier to get into. It's maybe less magical, but it's really simple. You create or you set up the injection by creating explicit bindings, which we'll see, which are a little similar to the functional configuration or the Java style configuration from Spring, where you bind things together manually. And also there are just-in-time bindings, as they are called in Guice, which is basically automatic discovery of the beans. If the classes have default constructors or constructor annotated with the inject annotation, the Guice finds them itself. You don't have to wire everything together. So this is Spring Guice, Google Guice in its pure form without anything additional, any Scala wrapper or anything like that. It's just extending the abstract module class, which is a similar pattern to the functional configuration we've seen. And in the configure method, you bind interface classes to their implementations. So here we are binding the water heater interface to a fast water heater class, which implements it. So we use this 3 times, and after we've set up the module, we can get the instances after creating an injector by calling this static method, create injector, and passing the module we've created. After we have the injector, we call injector get instance, and we ask for the class that we've created. Here it's the module does not bind the espresso machine because the espresso machine is not an interface, it's a class. So it's using the just-in-time binding. The espresso machine class will have to be annotated with the inject annotation. We have all these examples that you see here are right now posted on GitHub, so you can look at the complete sources and try them yourself. These are just snippets of code. So this is like Guice without anything added, and there are some additional stuff that you can add to the Guice library. There are little Scala libraries or wrappers that build on the Guice, and they can give you a little nicer syntax or more Scala-friendly syntax in creating the modules and the injectors. You can see here that the difference to the original example, the Scalified example module mixes in the Scala module trait. It's the Scala module trait comes from the wrapper, and it adds a different bind methods that don't need to be passed a class object, but they take type parameters, so it's a little nicer from the Scala point of view. And the injector is itself wrapped into a Scala injector that has an again, method not get instance, but instance, and you don't pass it to a class. It just has a type parameter. So a little nicer syntax, but like nothing to write home about. So let's sum up what we've seen in Guice. I think that the word that best describes Guice is simplicity. There's no like deep magic or anything like that. It's, if you want to use it, you just bring one getting started page and you're ready to go. I think it's, if you don't want some heavyweight dependency injection solution like Spring, you might want to look at Guice. It's I think a nice alternative. And it's, because it's so simple, it's really easy to integrate it in any existing frameworks or projects, even the ones in Scala. And the last example of the dependency, are there any questions to choose? Okay, no questions. The last Java dependency injection framework which we'll cover here is CDI, Context and Dependency Injection. It's actually a standard, JSR 299, and as it is a part of the bigger standard Java EE6, and it's contained in every compliant application server. So your JBoss 7, WebSphere 8, or any other implementation. And it's actually the newest of those, so it was created with lessons from Spring and Guice in mind. So it's quite well designed, but still not, I think, as popular as Spring or maybe even Guice. So let's look at it now. It's quite similar to the Spring annotation-based approach. The differences are that you don't use the automated annotation, you use the inject annotation, and you don't need component annotations on the classes. They are discovered automatically. You don't have to tell the container which classes are eligible. Also, you need a XML document, but in CDI's case, it can be empty. So typically you have less XML boilerplate. You just need it if you have some special stuff which we don't have here. By placing this file in a jar file or var file, you are telling the CDI container that you want it to inject the dependencies to the classes contained in that jar file. So it's basically, in this case, it's just a marker. And the CDI is its contexts and dependency injections. So what are contexts? Contexts are basically life cycles of the beans. So the typical ones that are used also in Spring is the singleton and prototype. Singleton, like everybody has singleton, right? It's just one instance that everybody gets, and the prototype or dependent, which is the term used in CDI, is the exact opposite. This one is created every time you need a dependency, a new instance is created. All other scopes, the session, requests, and applications, are scopes that are bound to some existing object in the application, like a HTTP session, request, or the application itself. And why I'm talking about this is that, for example, in CDI, only the singleton and the dependent scopes are injected as direct references to the other beans. Every other scope, like the session scope or request scope, is injected as a proxy. There are several reasons for that. One most obvious one is if, for example, you have a singleton scoped bean and it depends on, let's say, your request scope bean. So the life cycles are completely different. You can't inject a direct reference. So the framework creates a proxy at runtime, and it uses typically some thread local magic or ugly stuff and it resolves the right instances in runtime. So it knows which bean is bound to which session, which request, and so on. And to create the proxies, it puts additional restrictions on the classes, and these restrictions might vary a little between different dependency injection frameworks and basically between the methods how the proxies are created. The typical requirement is that those classes that are proxied need a default constructor, and they cannot have final methods, and they themselves cannot be final. If you require your V to have a default constructor, you're basically saying that it has to be mutable, because if you can't inject or add additional dependencies at the creation of the instance, you have to add it later. So that's one complication. And the other complication is that Scala compiler sometimes creates final methods in the generated bytecode, even if you don't write any yourself. So one example of this is if you have a val or basically a field in your class, and you use it later in a closure. In the generated bytecode for this, you would have a private final method for this, basically an accessor for this field that would be used in this closure, and that would make the class unproxiable, or could not be used in the CDI as a proxiable dependency. You could not put a session scope, for example, on it, and that's some maybe unexpected in some cases, but you can most of the times work around that. But it's important to know that there are some issues that are caused by some additional requirements on the bytecode that the Java dependency injection frameworks put on your classes, and those restrictions might not be met so easily if you write your classes in Scala. And that is all for the CDI, and here's just a quick summary. So I think the main message here is, if you want to continue using dependency injection frameworks that you know from Java, like Spring, for example, you can. There may be some, I would say, minor issues which you would have to sometimes work around or avoid, but you can continue using the stuff you know from Java. For some of the frameworks, there are additional wrappers or libraries that make the usage more Scala friendly, especially the Spring Scala project, which is, I think, quite important because the Spring itself, Spring source itself is developing it. So they're like putting their weight behind Scala and Spring interoperability, which is, I think, a good sign. And you may come or you may see some issues, as you see here, with the setters and proxies, which may bring some troubles, but the troubles are not insurmountable. You can work around or avoid them. So something you have to keep in mind, but I think it's not a really big deal. So that's all for dependency injection frameworks from Java, and we'll move on to something else.
Are there any questions? Are there any worries about using your favorite dependency injection frameworks in Java with Scala? How many of you is familiar with Spring or using it in Java? Please raise your hands. Okay, for the audience, many hands. There is Google Joyce. How many of you? Much less hands. And CDI? Yes. So basically, there is nothing to worry about, just about the some unproxyable stuff. I have a question about it. Would you find out compile time or runtime?
Runtime.
Yes.
Basically, every issue comes up in runtime. But that's nothing new from Java perspective.
Yes, that's because Scala compiles to my code not every time that's straightforward as Java, so sometimes you have to pay attention what's going on under the hoods. So no questions for this? Okay, thank you, Vlasta. Now we're going on with Scala-only stuff. We go into SubCut, which is a Scala dependency injection framework.
So hi, I will be talking about SubCut, which is a very small and simple dependency injection library written in Scala. It was created by Jakub, who you can see in the picture, and he is a well-known Java developer. Some of you might know him from the Java Posse podcast, and now he's an enthusiastic Scala developer, and he is doing the Scala Dex podcast, and you can see the process from the Java to Scala here. So, back to SubCut. SubCut is written in Scala, as I said, which makes it very nice for using. It is a binding DSL, and it uses Scala's implicits to cut down boilerplate rate, so you don't have to write so much code. There are 4 steps you need to do in order to use SubCut. Step 1 is to defining your components. So on this slide, you can see your component, which is water heater, and it produces hot water. And there are 2 implementations of water heater, fast and slow. There's just 2 implementations. So that's step 1. Step 2 is creating your configuration, or as it is called, the binding module in SubCut. In the configuration, you bind your interfaces or threads to implementations. And there are several options how you can bind them. You can either bind the interface to a singleton or one instance, or you can bind it to a provider, which means there is some code called every time you want the interface, and the code will decide what to return. In this case, it will always return a new instance of fine grinder. Or you can use a reflection and call 2 new instances of, and automatic former will be given back. So this is the DSL I was talking about. It looks very similar to Juice actually. Step 3 is defining your injectable class. Injectable class is another kind of component. The difference is that in your injectable class, you want to inject some of your dependencies. There are 2 important things. First, you need to extend from injectable thread. Thread is something like an interface in Java, but it can have some methods implemented. And the injectable thread gives us these methods: inject, inject optional, and inject if bound. The difference between them is that inject requires you to have some binding for water heater. So water heater is required. If there is none, it will throw an exception. Inject optional gives us an optional dependency. You can see here the type of former is option. So if there is none defined in our binding module, it will return no, but it will not throw an exception. And the last one is injective bound. It will either return the implementation given from the binding module, or it will use a default given here. So you don't have to have a binding in your module for grinder. You can use this one default. And the other important thing is this binding module. This is the configuration, the bindings, and you need to pass them via constructor parameter to our injectable class, so that the injectable trait can use it to look the implementations. And the last step is to just run it all. So here we have our espresso machine, that's our top level component, and we want to create it. So we need to provide it a configuration or binding module. There are two options again. Either we define it implicit, and then we don't have to pass it to the constructor here, or we pass it explicitly here. That's the thing I was talking about at the beginning. Implicits are Scala's way how to cut down boilerplate. So to sum up, the advantages of SubCut is that it's very simple, straightforward, and idiomatic. So if you use it, it's very easy. And there's no magic, and it's very nice in Scala. The disadvantages are that there's no automatic injection. It's as if in Juice. You have to inject your dependencies, you have to write the code actually, and it's similar to service locator. And there are possible runtime errors, but that's the same for every dependency injection framework except Cake, which we will be talking about in a minute. So, do you have any questions?
Always familiar with this framework? Who came across it, browsing internet for some Scala solution? Are you considering to look deeper into it, or will stick with Java frameworks?
Maybe is everything clear, or was I too quick?
So I have a question. Is it true that injectable class is now coupled to the framework, that every injectable class is coupled to the SubCut?
Yes, I guess. Yes. Yes, every injectable class needs to have this injectable trait here and the binding module passed in.
Some other questions regarding SubCut? Okay, thank you. And now Michal will talk about the cake pattern, which is the way how to avoid frameworks and dependency injections at all.
So, I'm here to tell you about the cake pattern, which actually is not really a dependency injection framework at all. It's just a Scala way how to do stuff without the actual injection and without any additional frameworks. So what it means, you can use the cake pattern as soon as you start with Scala. You don't need anything additional, you don't need to learn new libraries, you don't need any stuff, just the Scala language features which I will describe during the presentation briefly for the Java folks here, because all the Scala folks are probably already familiar with them and already know what it's about. So now how does the pattern look like? Imagine your application or the object you're building, the service you're building as a cake. In such a case, the application or service would probably
be the whole form of the cake, with the slices being different components that you use. In our case, with the espresso machine, the components would be the heater, the foamer, the grinder, while the cake being the espresso machine itself. Each of the components has a little cherry down there, which is an implementation of the component. So the component is the basic abstract interface that we need, or kind of interface, while the implementation is the specific implementation of the component. Here are two examples of how you compose the specific espresso machines from the different components. This is actually how the real code looks like on the top level. The whole machine is just this piece of code which specifies the espresso machine as the main tray, the main type that all the espresso machines actually implement, and it specifies the components with in different configurations. There's no need to add anything more to the any body to the object. Everything is contained in the trays already. Now let's dissect one of these to see what it is composed of actually. The first thing, pretty familiar for the Scala folks again, is the object keyword. That is actually optional, but what it means is that this type, the deluxe espresso machine, will be a singleton. Anyone who would refer to that will always get the same one. So you could do it the other way. You could use a class instead of the object, and then you can spawn any number of these if you need to. But usually you need only one instance of the actual service in the framework or in the application you're building. So that's the simplest way to do that. Then the other part is the top level trait of the espresso machines. That's the thing that declares what components we need to use, and we will take a look at that right here. The espresso machine is a trait. A trait in Scala is something like something between abstract class and interface in Java. So it means that you can have abstract component declared as a trait that can be instantiated. You can have some or all or none of the methods actual with the implementation. Here you can see that the espresso machine trait has an actual implementation. How to make a coffee. That's the reason why we don't need this on the top level object, because the trait already does have the implementation inside. So the trait knows how to create a coffee if it does have the grinder, the heater, and the foamer. Now we need to get those in. How do we do that? We declare a self type. A self type is a way how to create dependencies that are enforced by the compiler in compile time, and that we do not have to specify in the trait itself, but when we compose it with the other traits. I have a little illustration here of the different ways we can compose objects usually. The inheritance way is pretty clear. Probably we declare that each of the object is its predecessor. It implements all the methods, which is pretty much useless in our case when we need different components. We would need to implement all the methods in each espresso machine. So in the usual dependency injection way, as we've seen previously, we use composition, which declares that we have some grinder, we have some foamer, we have the water heater, and we will inject it in the espresso machine later. In the cake pattern, we use Scala self-type, which is actually a way how to tell that we need in the espresso machine tray, we need the heater, the grinder, but we defer to the actual implementer the decision which grinder, which foamer, and which heater it will be. And whoever is composing the objects will be enforced by the compiler to do it in a proper way. Now, how do the actual components look like? So here is a grinder component. Basically, all the components look the same. They declare a trait that provides the interface it needs, which means in the grinder component we have something that provides the grinder. That's the method, in this case abstract. And we have the actual grinder declaration, which says what methods does the grinder have. And this component then has the actual implementations. The implementations can vary. All the implementations implement the component on this level, which means that they provide in some way the grinder thing. In this case, it's a bell, which means that whoever is using this component will get basically a singleton again. It's just a singleton in the machine. It's the grinder is clicked only once for this case. Here is the part where we could use something like session scopes or request scopes, or create a grinder on each request by declaring, for example, instead of var, you could say that it's a def, which is a function in Scala, so it would be created on each access to this function. And then there's the actual grinder implementation, which says how are the beans ground. So back to the top level. From these components, again, we just specify them on the object instantiation. That's the only place that we need to compose all the objects together, all the traits together, with the main trait that implements the actual code to create the coffee based on the components. Well, what's good and what's bad? The good stuff is that it's already included in the language. You don't need to know anything more. You don't need to learn any new classes and stuff like that. Everything is statically typed and it's, as Scala loves, immutable. So that's the reason why there's no real injection. Everything is already there. You don't need to inject anything. And it's checked by the compiler that it's really in place when you run the application. And the compiler helps a lot in this case. So you should not get into any runtime problems while using the capability. Usually, there might be some bugs or stuff like that, but I'm pretty sure that it will be all figured out. The bad stuff, if you really like XML annotations, you don't get to use them. So I'm sorry, but you will be better off with Spring or something like that. And it's pretty addictive. So back to the language features, there are really just only these three things that you need to know, and you probably already know them if you know Scala: the trait, the self-type, and optionally the singleton. If you're interested in more details, here are some links to articles about K-Pattern and a paper from Martin Odersky where actually the K-Pattern comes from probably. So the slides will be up on the internet. I guess on the meetup group there will be a link to the slides so you can take a look later. And again, all the code is in GitHub, so including the K-Pattern, and it actually should work, so just take a look at that. And that's all from me. Are there any questions?
How do you like these solutions that Scala offers for not only dependency injection, but from broader topic of inversion of control? How do you compare it to the Java stuff?
We were just discussing if it was possible to use scopes, like you could have the scopes like you had in other frameworks. I guess my initial thought would be like you said, that instead of the val you would define some def for the class or whatever trait you need in there, and based on that you can define some scopes, but I'm not sure.
Yes, that would be the right place, as we have seen former slides. This would be the place where you could do that. Basically, the cake could have multiple layers. You're not restricted to only one. So you could create another tray that implements, using some thread local stuff or whatever you need, some scopes. And you could use this trait in these implementations to create the object in the right scope. So it's really up to you. There's nothing that would stop you from doing that.
So you have to write it yourself, but you have the whole freedom, the whole Scala.
Or if you have some favorite library that implements already something like that is reusable, you can use it here. You can use anything that there's nothing that will stop you using any code you want, really.
As for runtime injection, do I understand it correctly that you can instantiate a component in runtime by using a method instead of the value?
Yes, that's right. If you integrate component during runtime and you have some logic, you have some extra settings and stuff like that, you can create a code that will instantiate the component any way you like, if you need to. Everything is Scala. There's nothing more provided.
So, who got interested with the cake pattern after this talk? Great.
Thank you.
Okay, so thank you very much for coming. We would be very grateful if you fill in those questionnaires. And if you do want to, will help us to provide you more interesting stuff in the upcoming months. We will do this event each month, the last Tuesday at this place, depending on how many people will attend. If there will be less people than 25, it will be in a smaller room, but this one is reserved for us also. And every other month we will do some coding dojos. So you could bring your own notebook or just bare hands and code some pure Scala on our events. Thank you.